Okay, lesson 2, we're going to go to 18. So this is the real data value. That would be what the line told me. All right, a residual plot just has your residuals and your x values, or your explanatory variables. This is just your typical residual error. All right, so here are some residual plots right down here. So we got to match A, B, C with one of these. So this looks like it's negative. So I'm willing to bet, well, actually, before I get into it, so I really should say this. All right. If your residual plot has a random scatter about 0 r equals 0, good fit for the data. So this would be like, these are my residuals. So this would be a residual of 0, 1, 2, 3, -1, -2, -3. If there's a curve pattern, that means your line is not good for the data. So if you look at this point right here, my line is above the data. This would be a negative, that's a negative residual. So negative, negative. This residual is positive, positive. And then negative. So negative, negative. Negative, negative. Positive, positive, negative. These match up with each other. See, this almost looks like that. A line's not a good fit for this data because the data kind of looks like this, but the residual plot is showing me a pattern. That's not good. If a residual plot has a pattern, a line is not a good fit. So this one has negative, positive, negative, positive, positive. Negative, positive, negative, positive, positive. Those go together. This residual plot is random. So a line appears to be a good fit for the x's and y's in scatter plot B. And clearly this one goes with this one. And this residual plot, I mean, it's okay. It's kind of random. So a line would be a decent fit. I mean, that data sucks. Who knows what would fit that? But maybe this, I don't know. Maybe that's not a good residual plot. But it's 4 data points. Okay. Put this data in the calculator. This is some easy data. This is the data that I like. Small numbers, 4 values. Get right to the point. From some software that came from the 1980s. So go to test, linear regression t-test. Find the LSRL. That's the least squares regression line. That just means the line of best fit. 12.9. A plus bx plus 0.8x. Zoom 9. I'm just going to sketch this graph. All right, it looks... There you go. Graph a residual plot. Okay, so to graph a residual plot, what you do is you go to second stat plot, and instead of doing L1 versus L2, you want to do L1 versus your residuals. So if you hit second stat, go down to you see resid. You have to do the linear regression t-test first, because then it generates the residuals. Then hit zoom 9. So this is my residual plot. So it goes down, down, up here. This is like r equals 0. Comment on the residual plot. Well, it shows a pattern. There's not a lot of data here, but I don't know, you know what? I don't even know if that's a pattern. Here, appears random. This appears linear. But see, probably what I would have to do if I was really solving this question is I'd say, all right, it's got a strong R, that's a good sign. The graph looks linear, the residual plot looks kind of random. Probably, all right, p-value's pretty low, so I'm willing to bet that there is linear relationships. You would probably go off all of that stuff right there. So find the predicted value for x equals 3. Well, the predicted value would be, plug it in, 12.9 plus 0.8 times 3. $15.3. Find the residual for 15.3. Well, wait a minute. When x is 3, y is 15. This is the real value. This is the predicted value. So a residual is the actual y minus the predicted y, which is donated by y hat. So the actual y is 15, the predicted y is this. So we get negative 0.3. That's my residual. So at x equals 3, my residual is negative 0.3. When a residual is negative, that means the line overestimated by 0.3 at x equals 3. Because if you think about it, here's 3, here's 15. This is xy. Well, I have some line of best fit doing this. 15.3. So here's 3, here's 15.3. Well, that difference, that's a negative residual. My line is over-predicting at that point. Find and interpret the standard deviation of the residuals. Well, the standard deviation of the residuals is it's the S value right here. So our average residual is about 1. So these predictions and actual values are going to be off by about 1. Let's go to 25. and then go to the linear regression t-test. Okay, so LSRL, just going to copy it. So y hat equals a plus bx. All right, the slope of the LSRL is negative 0.25. So for each one IQ, that's the x value, increase, the predicted number of hours of TV, that's the y's, goes down 0.25. That's what that's saying. The y-intercept, so for an IQ of 0, see, y-intercept is when x equals 0. The predicted number of TV hours is the y-intercept, 38.7, which doesn't make any sense because you can't really have an IQ of 0. Well, I guess you could, but we're not going to get into that. Sample correlation coefficient, that's just the R. So R is 0.87. The R squared is the coefficient of determination. I'm just going to copy this right down. And the S is 2.4. Okay, R is 0.87. That's, strong, positive, linear correlation. Predict for an IQ of 130, so 38.7 minus 0.25 times 130. So the line says it's 6.2, but 130, the actual data point was 8. So the residual y minus y hat for 130, the actual y is 8, the predicted is 6.2, so we're going to get 1.8. So at x equals 130, the least squares regression line under predicts by 1.8. So when the residual is positive, the LSRL under predicts. If the residual is negative, the LSRL over predicts. That's straightforward, because if I have an x of 130, the actual data point was 8, but the line of best fit told me 6.2. So the line is under the actual point. Okay, R squared, this means about 76% of the variation in the y values is accounted for by the LSRL. In a nutshell, 76% of these points, it's not the real definition, but actually, no. About 76% of all these points, the line of best fit, which is this, is accounting for. Like maybe this point isn't best suited for this line, but the fluctuation of all these different y's, the line is accounting for those fluctuations. So if you're if you get older and you happen to see an R squared in some sort of research paper, that's kind of what you're going to think. This line is good for about 76% of the points. Maybe if I did like an exponent, like a quadratic regression between them. It's going to give me this formula. Then if I, oh wait, look at the r squared. It's 0.85. That's higher. Maybe this is better than the LSRL. So then you'd have to graph the residuals and see which one had a better residual plot. That looks pretty good. I bet this is an exponential function, but that's okay. And 2.4 would mean the average residual is about 2.4 from 0. The average residual is about 2.4 from 0. So it could be positive or negative away 2.4. Okay.